David Smith here with another flipped classroom math lesson. A few tips before we start. First, remember that you can speed up or slow down the playback if that helps you follow along. Second, you can turn the captions on and read my words on the screen. Third, you can pause the video at any time to catch up with your notes or write down questions for class. Today's topic is sums of geometric series. So we've been working through a unit on sequences and series, and this one we're going to take a look at geometric series. So a little review. Geometric series and sequences are those that increase by a common multiple, or multiplying the initial term by the same number every time to get the next term. The difference between sequence and series is when we use the word sequence, we're just talking about the terms in the sequence. We might want to know the 20th term, or we might want to know the common difference, the common ratio. Now, when we talk about series, we're talking about the total of a finite series. So say from 1 to 10 terms, what do all those terms add up to? So that's what we mean when we talk about series. Okay, so let's take a look at the formula for calculating the sum of a geometric series. It's a little more complicated, but not too much. So take a look. So what we have is Sn equals U1 times r to the n. And remember, r is the common ratio, r to the n minus 1. So this little term times u1 over r minus 1. Now there's an equivalent formula that you can use as well. It gets you the same result. And all that happens is the r to the n and the 1 switch positions. So this was r to the n minus 1. Now it's 1 minus r to the n. In the same place down on the bottom, it's just 1 minus r. Let's use the formula and do an example. Okay, here is our series. 7, 28, 112, 448. So take a look at our formula, figure out what you need from the series, and see if you can write the plug-in step for the first step of this calculation. Okay, so the first thing you needed to do was write down U1 and R. So U1 is pretty easy. U1 is just 7. And R, if you look at these numbers, you're going to see that you just multiply each successive term by 4 to get the next one. So our R equals 4. So if you couldn't do the plug-in step before, pause the video now and try your plug-in step. Okay, let's see how you did. So S8, remember we're doing 8 terms, is going to equal 7 times 4 to the n, which is 8. So 4 to the 8 minus 1 over 4 minus 1. Okay, so pause the video and crunch those numbers. Okay, let's see how you did. When I crunch the numbers, pop them in my calculator, this is what I get. 152,915. Now that's a big number, but when you think about it, these things are growing quite quick. So we're multiplying each one by 4, so the successive terms are going to start getting really, really big. And that's what we mean when this is a geometric sequence. The terms grow geometrically, or another way to say that is exponentially. And remember, exponential equations have their variables in the exponents. And you can see that makes this an exponential equation. Okay, let's do an example problem. Pretty simple, big numbers. Okay, so school tuition fees, this was probably a boarding school, in Japanese yen, JPY, are 2,500,000. Okay, the fees increase by 2% each year. Okay, so they're going up by 2%. The first question is, what is the tuition at year 6? Okay, so this is going to go back to finding the nth term of a geometric sequence, and that would be this formula, un equals u1 times r to the n minus 1. So un, so we're going to do u6 equals u1, which is 2,500,000, times r. Now, we have to remember what r is in this case. 2% is the actual increase. So to get the next term, we have to keep the 1 in there. So that's 1.02. So that's going to give us, the 1 is going to make this, keep this 2,500,000, and the 0.02 part of that is going to add 2% of that to the number. So that's our R, and then n minus 1 in this case would be 5. So go ahead, pull out your calculator, crunch the number, see what you get. Okay, when I crunch the numbers, here's what I get. I get 2,760,202.01 Japanese yen. So that kind of makes sense. It's only going up by 2% per year. So we started at 2,500,000. After 6 years, the tuition is 2,760,000. That seems reasonable. Okay, that passes the reasonableness test. All right, now let's do a sum problem. So this one is, how much total tuition will be paid after 6 years? Okay. Now remember, there's a shortcut here that could cause you to lose points on an IB test question. You could just use this formula, calculate the tuition for each of the 6 years, and then add them up. Okay. So if that's a 3 or more point problem, taking that approach won't get you all the points. You're going to need to use this formula. In fact, I think it's a really good idea whenever you're asked to calculate a sum of an arithmetic or geometric sequence that you use the sum formula so that you can demonstrate that you know how to use that, and that way you'll ensure that you always get maximum points on an IB test question. All right, so you have your information, you know your U1, you know your R, here's your formula. Go ahead and pause the video and do the plug-in step. All right, here's my plug-in step. I want to call your attention to something. Remember when we do the nth term formula, the exponent is n minus 1? You need to keep this straight because with the geometric sum formula, it's just the n. It's not n minus 1. So in this case, here we had n minus 1, we had 5 to find the sixth term, the number of the sixth term. But to find the sum of all the terms up to 6, we use the 6 in the exponent. Okay, so here's my plug-in step. If you didn't get that far and you waited to watch the video, great. Now do that calculation and see what you get. Okay, here's what I get. 15,770,302.41 Japanese yen. And remember, this is money. So you've got to put 2 decimals in there. That's the rule with money. Okay, let's do a second example just to bring this understanding home. Okay, this one's more abstract. The second term of a geometric sequence is 6. And the fourth term is 24. Okay, so we don't really know what the first term is, and we don't know what R is, what the common ratio is. However, we're going to find the common ratio right there. Now, I understand that if you stare at these 2 terms, you can figure out just by inspection what the common ratio is. However, that may not always be the case. So let me show you how to calculate it to be sure you can find it every time. Okay, so what we can do is we can pretend that that's the first term. And if that was the first term, then this one is going to be the third term, right? Okay, so what we can do, here's our formula. UN equals U1 times R to the n minus 1. So 24 would be the third term. So 24 equals the first term, 6 times R to the n minus 1. Now we are at n equals 3, so this would be r squared. Okay? So that takes a little critical thinking, but it's not bad. Okay, now we're going to divide through by 6 to get the r squared alone. 24 divided by 6 is 4 equals r squared. And so you can see pretty quickly that when you take the square root of r, you're going to get r equals 2. So our common ratio is 2. Okay, before we do this next one, did you notice the mistake I made up here in my writing? Take a look, see if you can find it. Fourth is not spelled that way when we're talking about numbers. That would be F-O-U-R-T-H. Oops, good thing I'm not an English teacher. All right, find the first term. Okay, so pause the video right now and see if you can do that. You're going to use this formula and some creative thinking. Okay, let's see how you did. So we know that 6 is the second term. So 6 equals the first term times r, which we know is 2, to the n minus 1. We're looking at the second, this is the second term, so this is going to be 2 minus 1, or just 1. So now we just divide through by 2 to get u1, and u1 equals 3. So pretty straightforward. Now we know our first term. And you can guess where this is going to go. Now that I know the first term, I can do a sum. All right, so here's the question. Find the sum of the first 10 terms. So go ahead, pause the video, and see how far you're going to get that. I'm going to bring you to the plug-in step next. So if you couldn't get that, then you'll get that. But then I'm going to ask you again to see if you can follow the calculation all the way through. Okay, so here's my plug-in step, S10. sum of the first 10 terms of this sequence equals the first term, that's 3, times the common ratio to the number of terms we're summing, so that's 2 to the 10th, minus 1 over 2 minus 1. So that's the plug-in step. Go ahead and pause the video and crunch those numbers and see what you get. Okay, when I crunch the numbers, I get 3,069. If you can't get that, try it again. Make sure that you can get that number. All right, that's the end of the sum of geometric series video. Now remember, when you do the IB test questions, or just even the IB homework exercises, they're going to come at this idea from different angles, some of which will be new to you. So just do this. Calm yourself down if you get a little bit anxious, and remember, you do have the skills to do that. And then know when you come into our next class, if you need some help, I'm going to help you. But remember this too, that if you need help and I show you or someone else in class shows you, when you get it, you're going to go, oh, that makes sense. So think about that now. If you get stuck on any of these exercises, remember that it will make sense and maybe you can get there on your own. Now that you've finished the video, take a moment and jot down some notes or questions for our next class. Remember that you can also watch the video again if you want to increase your understanding. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.